Well, good morning, good afternoon, wherever you are. Welcome to another exciting TBC Power Hour. Today we will be talking about TBC cadastral workflows, mostly focusing on some of the recent enhancements in TBC around establishing corners, labeling, creating survey plats, and more. My name is Boris Kopjak. I'm going to be your host today in absence of our designated product manager, Joe Bleka, who's on travel. Together with me in the room, I have Matt McLean, who's working with our TBC team over the last couple of months. Matt, I'll let you introduce yourself.
All right. I started with Trimble a few months ago, and I'm now um, here doing this power hour. I suppose I'm here to show what I can do and where my experience lies. I started off surveying in Western Canada. Um, I then went to get my geomatics engineering degree because surveying is pretty cool, and here we are to continue on with my learning. Um, Thanks for the introduction, Boris.
Well, thanks, Matt. Matt is going to be kind of focusing on the live demonstration and show you how things work in TBC. So the agenda for today is really to kind of elaborate a little bit more why have we been investing in the cadastral workflows in TBC, and how does that fit kind of TBC's mission statement of being field to finish software for surveyors with confidence. Uh, we will then kind of briefly go through the list of some of these recent cadastral workflows, and we will kick it into a live demo. So the session is optimized really to spend about 30 to 40 minutes on the live demo, leaving us 10-15 minutes towards the end of this session to cover any questions. So please make sure to type questions in the chat window as we go, and we will try to make breaks and address your questions as they come in. We will wrap it up with some of the resources and next steps on how to get started with TBC. So when we talk about field to finish with confidence from a TBC standpoint, what do we really mean? So our users typically start with bringing in field data, and things that we are proud of in TBC is that we bring more geospatial data in the raw form than any other office software. So here in the plan view, you get to see RTK total station observations. In the same environment, you get to work with point clouds and images, and it's all one dynamic, seamless environment. So I changed the backside to a prism constant has an impact on a point cloud, has an impact on an image. So where in the past you had to use 4 or 5 different software packages to handle different nature of survey data, now you can use TBC as your geospatial data hub. Once you get get that data in the software, then you start with kind of massaging the data, doing adjustments, traversing, doing your calibrations. And Kogo is an area where we've been putting a lot of emphasis on. So some of this is going to be shown by Matt today on how to kind of create this type of a parcel geometry and how to report on disclosures and so on. CAD and drafting, we could not be able to call ourselves a complete survey package if we were not able to produce that final survey plat or survey topographic map deliverable. So that's another area where we've been investing a lot of energy into. Scanning, very popular in TBC recently with the SX10. A lot of effort kind of going into introducing additional capabilities and more automation around scanning. Uh, Similar with photogrammetry, with the addition of the US master, you have the ability to bring in any drone data into TBC environment and process that to get the final point clouds and orthophoto and DSM deliverables. Surfaces and volumes kind of tie into that workflow where TBC does a good job in creating those surface objects, creating your contours that you can then put on a piece of map, or you can export these to Trimble Access or machines for stakeout and earthwork operations. And then corridors, that ties in quite well with the Trimble access routing. We've recently enhanced corridors by adding the support for tunneling, if you have missed that one, so another exciting addition to TBC. So really the emphasis around Cadastral is a key for us to have a complete survey solution in a single package that would increase productivity and lower project costs for our customers, as you can see a statement here from one of our users. So some of that recent cadastral workflows that we've enabled is ability to create parcel geometry in TBC through the create Kogel command that allows a lot of flexibility, not just for parcel creation, but also for CAD geometry creation in a more of a command line approach. Once you have the parcel of geometry, you can compute misclosures. Initially, we were able to compute misclosures from the entered geometry, but today we will show how you can also compute misclosure from the existing labels. We will also kind of cover this labeling of grid versus ground distances, legal descriptions. We won't go in the detail of legal descriptions. We've covered that. We had a session, TBC Power Hour, on legal descriptions in October, so we may kind of just remind you and show you where it is. But for detailed overview of how legal descriptions work in TBC, would recommend you kind of revisit that Power Hour from October of 2017. We will show the single and double proportioning and how to retrace your monuments in case you cannot locate them in the field. We added some interesting kind of a workflow enhancements so you can display dual units in TBC, so you can be viewing meters and feet in the same project, or what in the case we're going to show chains, for example, together with your survey feet. And then all of this kind of comes with, it ties into our drafting workflows as well as a set of reports that came with all of these capabilities. So with that, I want to kind of pass it over to Matt, and he can take us through the live TBC demo and show you how actually things look like in practice.
All right. Thanks for that introduction, Boris. All right, here we go. So this is most of a plan from southern Colorado. It shows there's a township and there's the sections. There was a survey conducted by the Bureau of Land Management, and we have some of the sample data from that survey. They conducted a survey on section 2, 3, 4, and 5. So I'll be focusing kind of in this area around 2, 3, and 4 today. We'll do some single and double proportioning off of these plans, or this plan rather. This is a little bit more zoomed in. These gives our azimuths or bearings. In this case, bearings. It's the United States plan, and our lengths are in chains. One chain is 66 U.S. survey feet. That is how the public land survey system was surveyed originally, and consequently, that's how all the plans are. Excellent. Let's get into it, shall we? So single proportioning, for those who might not be aware or need a refresher, if we have found these two monuments in the field, the two corner section pins of section 2, and we want to reestablish the center or the quarter section line, you can't just take the so you'll have a measured distance between the 2 points, and you'll compare it to the record distance of 83.15 chains. Any difference in that distance has to be proportioned evenly, or not evenly, sorry. It has to be distributed in proportion to the record distances of the section lines on the plan. So here it's 40.5 and 20 plus 22, so about 42.5. So it's a little bit longer on the northern portion than the southern portion, so the error has to be in proportion to that. So it's the section, or the center quarter section pin that we're looking for. That's single proportioning. For double proportioning, it's if we've got a marker to the north, east, south, and west, double proportioning, in a sense, does single proportioning twice, but there's a little bit more to it. You take your bearings, you convert them to your cardinal equivalents, and then you follow the rhumb line between the two markers in each direction, and then that's how you establish the point in double proportioning. All right, and this is the point we're looking for. Let's jump into it, shall we? Here's the data set from the Bureau of Land Management. I've already changed my background color to white to make it a little bit easier to see. And these are the RTK vectors with which the points were measured. At first glance, it's a little difficult to line up what lines to what on the plan. So I've gone ahead and I've georeferenced the plan into the background to make it easy to follow where our points are at. Our point numbers blend in with the black lines a little bit. So I'll touch this up a little bit, go into our imported image, properties, and I'll set the transparency to 50% to make it a little easier to read. That's better. Black still blends in a little bit. So I'm gonna go up here. Let me turn on my, there we go. A little bit nicer to see, hopefully. Go to CAD and our layer manager, and we'll set our points layer to be, let's do purple. See if the purple shines out a little bit better. Yeah, that looks better. All right, now into it. So here's our section 2. In the demonstration, we found this marker and this marker to reestablish this point, but this point was found in the field. So let's go ahead and use single proportioning to reestablish this section marker right here. The single and double proportioning commands are underneath the CAD portion in the ribbon, in the COGO section. Single proportioning. First off, you might notice under calculation type, there's a planar calculation and a grid calculation. Or sorry, planar, which is a grid calculation, and geodetic. The planar calculation is very simple. It essentially draws a straight line between the 2 points and then proportions accordingly. The geodetic calculation, it uses the rhumb line between the 2 points. A rhumb line is a line of constant azimuth. When you're running north-south, it'll be close to the straight line, but it'll still be a little bit different. Running east-west is where it's different. The rhumb line will actually curve a little bit below to match with the curvature of the Earth. When you're proportioning, it's important to know and understand how the original survey was carried out. And the original surveyors walked along and they used a compass and they sighted to Polaris to check their azimuth as they surveyed. So they were following the rhumb lines. So it's important that we can proportion along those. So with single and double proportioning, the TBC help recommends that you use geodetic for a distance longer than 1 kilometer, which is about 2/3 of a mile. But it would be, unless you're using curves in your project, it's good practice to always use geodetic as it will give you the best values. For a start position, there's a few different ways you can enter in a value. You can click on a point on the plan view and it'll end up in there, or alternatively, you can type in your point number. That one's 600, 640A, so I'll type that in. Additionally, if you have a line segment along this line, you can use the line segment and it'll use the start and end distances of that line segment. Here we have a right side up triangle that represents the start of the line, upside down represents the end. That's important for entering the record distances as order matters. So here we have our first record distance, which is 22.38. And this is in chains. So in TBC, you can enter in CH for chains. Pressing the tab key or the enter key brings you to a new record distance line. Oh, hold on though. 1,477 feet. How do I know that that's doing chains? If we go up here to the project settings, another addition under units distance, if we go down to alternate unit, we can have an alternate unit displayed. Let's go on and let's choose chain. The abbreviation is CH, and our decimal precision, let's go with the 3 decimal places. That should be adequate for our needs. Oh, here we go. 22.38 chains. Awesome. That looks great. So now our second record distance is 20.26 chains. When it's displaying the alternate distance, you still have to specify, because our project unit is still set to US survey feet. Our fixed distances, if you have, say, a road allowance in your plan that you need to maintain that distance when you're doing your proportioning, you can enter that in here. For this, we don't have to worry about that. And now we select our starting point ID. Let's go with 10,001, and we'll set the layer that we want that point to go into. I have a proportioning layer set up, and we'll go with that. If you're using a line segment, you might want to create points at the starter end. Since I don't have a line segment, I'd like to have this create lines. And let's create a report so we can go through that together. All right. Swirl of reports generating. Here we have our point 10,001, and we have our line segments that were drawn. Here in the single proportioning report, we have our project data, our coordinate system. We have our starting and ending point, our forward and reverse azimuths. These are the azimuths that follow the rhumb line from the 2 points that we're proportioned from. We have our geodetic azimuth and our grid azimuth, and then we have measured grid and ground distance. They are a little bit different. We're going a little bit over a half mile here, so the difference between grid and ground will become apparent. We get our point coordinates and our point statistics, including the grid, elevation, combined scale factors, and any feature codes that we've put in place. On the second page of the report, we have our proportion segments. We have our grid azimuth, record distance, proportion factor, grid distance, and ground distance. The important thing to note here is this record distance are the numbers we entered, so we can check to make sure that they did get related to, or that they are close and similar. The proportion factor is the ratio between these two, so we want to have a proportion factor that's close to 1. And that means that we haven't made any mistakes and that our survey points are most likely the correct monuments. So there's extra added confidence there. And then there's a drawing of the line with the points that were proportioned. If I had the labels, or if the line was labeled, it would be labeled here as well. And then the third page is just a little more information. Excellent. So there's the single proportioning from points. I'll put a polyline on here for the west side of section 2, so you can see how that works. So I'm going to select a line segment here. Oh, need those. So we've got our line segment for our record distances. We've got 22.325 chains for the top. Sorry. I'll open up the single proportioning window again. There we go. And then we have our right side up triangle for the start, upside down triangle for the end. So it's going top to bottom. Boris teased me when we did a practice run of this that I went from bottom to top, so I made sure to do it the other way around this time. So we got 22.325 chains for our first record distance, tab or enter to get down to another line, and 20.295 chains for our second distance. We'll set a point number here as 10,002, and we'll choose the proportioning layer again. I don't need lines because I have a line already, and we don't need to see the report this time.
Seems like we still need the point IDs.
My polyline doesn't have a 3D. That's
the polyline instead of line string.
My bad. We'll delete that line. Select the line. It's on there. 22.325 chains and 20.295. 2 proportioning. There we go. The polyline I drew was just 2-dimensional, and we need a 3-dimensional in order to adequately calculate the geodetic distance, because the rhumb line is related to the projection of our coordinate system. There we go.
Interesting how the 10,002 aligns better with the PDF than the 10,001.
That is interesting. Plans drawn by hand.
Yeah.
So we'll give them the benefit of the doubt. They're pretty close there.
Yeah.
All right, so there's our single proportioning. For our double proportioning, we're going to reestablish this section corner between 3, 4, 9, and 10. We're going to use these 4 points as our directions. I'm going to turn off the RTK vectors just to clean up the view a little bit. And go up here, again, the CAD ribbon under COGO for double proportioning. This window's, if you're familiar with the single proportioning window, this one it'll feel familiar to you as well. We have the same planar geodetic calculation. Again, unless you have curves, you should always use the geodetic calculation. So then you choose the direction, you enter your known position. Same thing, you can type in a coordinate name, or you can type in a coordinate, a point number, or point ID rather, or click on it in the plan view, your azimuth, and your record distance. So, point to the north, the azimuth. Here you can enter in your azimuth, you can enter in a bearing. So long as you follow your project settings of degree, minute, seconds to decimal degrees. I don't know of any surveyors that use decimal degrees, however. So for my bearing, I have north, 0.27 west. It can be upper or lowercase letters, spaces or no spaces. TBC is smart and will recognize what you mean. When you click away, it switches, and so you can see that it's north 27 minutes west. For those who aren't familiar with bearings, the way they work is this is in the north direction, and it's 27 minutes west of north. If it was east of north, it would be north 27 east, and then same with, so bearings measure east or west of north, or east or west of south. As azimuths measure, they start at 0 for vertical or upright, and they go to 90, 180, 270, and then back around to 360 or 0. I'll continue on here. 40.06 chains for our record distance. Again, you can tab or hit enter to enter a second record distance, but we just have the one here because this is the point we're going for. So we go over, or let's do this on our first step. Starting point, let's do 10,003, proportioning layer, and I'll get lines and report when I'm done, so that's good. To the south next. Our bearing is north 7 minutes east, north 0.07 east, and our distance is 39.04 chains. With the unit, you can have a space or no space between the number and the unit. TBC is smart and can read through your inconsistency, or my inconsistency rather. To the east, this is north 89.50 west, and the distance, and there's the two quarter section lines, or there's the full section line here, 80.05 chains. For those not familiar with chains, there's...
Hopefully you didn't put the CH.
Oh, good catch, Troy. Thank you. I knew I was going to do that at some point. Important to do units, otherwise TBC thinks you're working in feet, as any sane person would. Our azimuth is 89, or south 89.41 west, and our record distance is 40.13 chains. So we have our 4 green boxes. That signifies or indicates that we've completed all 4 cardinal directions, or not cardinal directions, sorry, just directions. The double proportioning routine calculates the cardinal equivalents of the bearings in order to do the proportioning. While the report's generating, we have our 4 lines created and our point. Excellent. If we want to compare, we can go into the drop down on the measure distance to inverse, or alternatively select it from the quick access toolbar. And then in the inverse command, we can go from between our 2 points here, and it gives us a grid azimuth. We get a geodetic azimuth, both forward and backward. That's from our start point to our end point along the rhumb line. They're slightly different because the line curves slightly to the south as it goes. We have an ellipsoid distance, a ground distance, and what was the other? So the new addition here is we have a grid distance and a ground distance listed, as well as the geodetic azimuth, if that's something that you need to extract from your data. So the ground distance here is 80.045 chains, and our record distance was 80.05. So everything looks good so far.
Could I just interject one thing?
Yeah, absolutely.
With double proportioning, the curvature of the rhumb line is not nearly as pronounced. That curve actually goes to the north, and it's because the north-south component of your point is fixed by the cardinal equivalence in the north-south direction. It's not fixed so much by the curvature of the rhumb line.
Okay.
So what you said was true for single proportioning, but it's a little bit of a different story for double proportioning.
So it's curved to the north a little bit here because
the cardinal equivalence north to south pulled the point north.
Okay.
So the north-south component is fixed by the north-south distances. The east-west component is fixed by the east-west distances.
Show us the report.
Yeah, hop over to the report. So that's a good point. If we'd been doing single proportioning from east to west, the line would be curved a little bit down because we're in the northern hemisphere. I guess in the southern hemisphere, surveys wouldn't be, it would be the other way, but you would cite the south instead of citing the north. So here in the double proportioning report, it's very similar, except there's a little bit more information. We have our calculation, or our points for the north-south line, as well as the east-west line. We have our grid and ground cardinal equivalents and our measured distances. We have our point coordinates, point statistics, much like on the single proportioning report. And then we have our our records, the comparison between our record distances, our cardinal equivalents. And then we have here, this is where the important information on the single report is. This is where it is on the double proportioning report. We have the north-south proportion factor and the east-west proportion factor. These numbers are both very close to 1, so we are in good shape here. That's a good sign. And then, just like in the single proportioning report, we've got a chart that shows us where all the information that was required for our double proportioning calculation. Excellent.
So everything that Matt is showing here is available in TBC Advanced. So if you have TBC Advanced today, you will be able to kind of follow the exact same steps that he's done here. So I hope that answers your question, Ty.
All right. So there's single and double proportioning.
Just curious, Matt, how many points did you use to georeference the map background?
I used 3 points.
Okay.
I used, I believe I used this point over here, or I used the point just over from the one with the flag, this point up here, and then this one down here. Okay. So I used 3 points as far away from each other as possible. You can use more points than 3. Yeah. Then I believe it'll use least squares in order to best fit the image.
Correct.
Yep, that's correct. But 3 is the minimum in order to solve for the 3 unknowns in positioning the image.
Hope that answers your question, Mel.
Any other questions? No, so far so good. Very easy to answer at least. All right, so we'll move on to our workflow demo number 2. Parcel misclosure and labeling. Here we have a subdivision. This is from southwestern Ohio. So yeah, we'll jump right into it. what I will be demonstrating with this is when I was surveying in Western Canada, I was doing mostly legal surveying with new home construction and subdivisions. So the first thing I would do when I got to the site is I would actually go and I would take the lot that I was building it on. For my demo, I'll be doing 9,076, this one right here. And I'd go and calculate the boundary of the parcel to make sure that it closed properly. And occasionally I'd find one that didn't, and at that point it made my day's work quite easy to do, because I would send the plan back and ask for something that was better. So it was a little bit labor involved. I'd use my HP calculator and go through and calculate it out. Then I'd inverse between my start point and my end point. So it's very easy to do in TBC now. And then after I do that, I will go through and I will label subdivision to make something that looks nice like this. And then we have our curves with an associated curve table. This is a curve table from a smaller subdivision. I put it in here for demonstration's sake. This one had a lot more curves and it wouldn't have fit the slide. Anyhow, the important thing to note here is that we have custom parcel labeling in TBC. We have our grid and ground distances listed. Some people use grid, some people use ground. Now you've got the option to choose between them. And we have our azimuths labeled. It's all the bearings rather. Sorry, the Canada rubbing off of me. They're all rounded to the nearest minute here. In TBC, you can select to round to the nearest second, 5 seconds, 10 seconds, 20 seconds, 30 seconds. Almost any angle that would make sense to you. That way you don't have to over-represent the accuracy on your deliverable. Excellent. Let's jump in, shall we? So here we go. A similar thing. Typically, you'll have the paper plan in front of you on your desk. I have it in the background for ease of presenting. That way, I don't have to be flipping between two windows or anything. This is just going to be a lot nicer for us. On the plan, if you tip your head to the left, you can read whereabouts this is. It's in Fairfield Township, Butler County, Ohio. That's southwestern Ohio. And then here we have a benchmark elevation of 711.93 feet. In order to do the grid and ground, we'll go into our project settings, coordinate system, local site. I've entered in a latitude and longitude already, as well as the project height that was indicated on the plan. This will allow TBC to accurately calculate the scale factor. So when you click on the local project settings, as I did there, you can go and you can select what type of coordinate you want to enter, and then you can calculate a scale factor. All right. So here, I'm going to calculate the closure of lot 9076. I'm going to use the create COGO command. It's in the CAD tab under COGO, right next to single and double proportioning. That way, in case you lose your bearings, they're all together. All right. So I'm going to create a new collection. Let's call it something original, like lot 9076. We'll put it in the COGO layer 9076. I like consistency. We'll automatically create lines, automatically create points, and let's start at point 1. There's only going to be 6 points in this parcel, so that should be good. And we'll put this in 9076 as well. Because we have a project height, we don't need to have 3D elevations. And let's use ground distances for a horizontal distance. If this is set to 1, you can hit calculate and it'll update based off the scale factor you have set up in your local site settings. And for curve distances, you have a few options here. There's a Z rotation in case you have to adjust for your magnetic declination, or is that what it's called? Yeah, magnetic declination on an older plan. And for the power users in the audience, there's a numeric keypad mode. I'm not going to touch into that because I'll be this is more an introduction. So here we have the COGO window, big window waiting for you to type things. Scary, I know, but don't worry, it's not intimidating. You don't have to type if you don't want to. There are these 4 easy to use buttons down here. Start, That sounds like what we want to do. So we can start by coordinate, start by point, start by offset. These letters on the side, this is what you'd actually type in. So for start by coordinate, SC, it enters an SC up here. For start coordinate, you can enter a coordinate, or alternatively, you can click on the plan view. I think I'd like to start down here. Excellent. So here we have the coordinate entered, and you can have optionally a point ID. I'm going to call it start. And you can hit the enter key or click on new line, and it'll go down to a new line. So now we want to add a line. There's many options here. There's a great YouTube video done by Riley Smith for the TBC 3.80 release that goes through what all of these individually do. I have yet to use anything other than line by bearing. So I've also used line extend, which takes a previous line that you're building off of and just extends in the same direction. So those are the only two I've used so far. Line by bearing, easy to use. You can click in the plan view if you have a point here that you just want to snap to, or alternatively, you can type in the bearing, either in the bearing box or in the text box up above. So north 35.3649 east. Tab over to the next box for length 94.33. This is in feet. Our project's in US survey foot. Perfect. And enter our new line. And here we have a line drawn up to the next corner. So far, the plan is matching pretty well. I've already built this out and georeferenced the plan. If you put a plan in, it's a very small chance that it'll line up on your first try. So you might have to, you'll have a paper plan in front of you on your desk, which is what I would prefer to be doing too. So now I want to do another line by bearing. Instead of using the box down here, I'm going to type it in. So LB space. I'm going to get rid of that text command on the bottom of the window. Is going to get annoying. So that's okay. There we go. Now you won't have to watch me type on the screen. So line by bearing. This is north 2757 west. So north, again, just like in the single and double proportioning, capitalization doesn't matter. 0.2757 west, and comma, just like in the second line, follow the same formatting, and then 63.31 feet. Enter, new line, and it creates a line segment and a point up to our next intersection. So now, again, LB, this bearing is heading the wrong way, so we want to reverse it. So that's south 88.1830 west, comma, and our distance of 53.68 feet. Enter. Oh, we have another line segment. And now, where's this bearing? Way over there. Okay. South, or LB, south 74.49.20 east, west. Yeah. Thanks, Troy. 644.90. Excellent. So the purpose of the...
Do you want that? You probably want the 6305 or 03.
You guys are keeping me honest. I like it. 63.03 feet. That's better. I would have caught it eventually. All right. So the purpose of the create code command is to increase your efficiency in the office. So bouncing between the keyboard and the number pad to enter your bearings can be inconvenient. So instead of typing in south and west, you can also enter in what's the
quadrant?
The quadrant
number. That was.
I forgot this word last time.
It'd be
I don't know why. So it's the
first.
same. It follows the azimuth. So from 0 to 90 on your azimuth, it's quadrant 1, then 2, then 3, then 4. So this one would be quadrant 2. 2 space, and this is 1047.01. 10.4701, comma, and 115.49 for your distance. And voila, there it is. Now for the curves, there's many different options here. The one that we want is, the one you use would relate to the information that you have about the curve. For this curve, C16, we go down here to our curve table, and we look at C16, we have a delta angle, radius, length, and chord. So using that information, this arc by bearing of chord would work. So ABC, and we can bearing of the chord. So this column for C16 is south 77.3506 east. Excellent. Our radius is 50 feet. Our arc length is 40.49 feet. And optional point ID feature code, so new line. Let's see how that turned out. Excellent. And there we go. There's our parcel, directions done, and 7 lines of text. Not bad. If you draw the arc and it's curving the wrong way, that's controlled by the sign on the radius. So if this was negative 50 feet, it would curve the other way. I had it the right way first time though. I'm a natural. Excellent.
Is there any misclosure there, Matt? Can you zoom in?
Yeah, let's zoom in and take a look, shall we? If you click on the line segment, it'll highlight the line in the text that is related to that segment. Also, if you click on the line of text, it will highlight the line segment that is on the plan view, so the two of them work quite nicely together like that. If we zoom in, there's some misclosure there. TBC is the next workflow I'm going to go through. Actually, we'll quantify that misclosure as well as the direction of it. So here in the Map Check tab, choose the layer I want it to go in, 9076. This maximum misclosure is how much misclosure you will allow in your job before it doesn't actually generate a parcel. And you can opt to skip some with more than, or 2 or more misclosures, and there's a few options here. So we want to select our line work and create parcel.
Well, that selecting line work was unnecessary because it already knows what line work you have. Just
okay.
a time saver.
Okay.
Because the line work was defined on the COGO tab, it automatically knows that that's the line work you want to use.
I learn something new all the time. Okay, so there's our parcel.
So parcel was created because our misclosure was less than this maximum defined misclosure.
Correct.
That's correct.
Otherwise, you would see a warning there and a message, parcel failed to create.
Let's make the misclosure really small. Remove our parcel and then create one. So one parcel failed due to too much misclosure. So our misclosure is more than 2,000 square foot. Good information. Excellent. So parcel's created. If we want to rename the parcel, I'll do that later and show you how that works. To label the parcel, choose a layer for our labeling to go into. You can opt to have small segments put in a table if you're working on a larger project area. The parcel is already selected, and let's add labels. Oh, do not fear. It looks messy, but it's easy to fix. Drafting layout style manager. The text is quite large, so let's go down here to here you can create your own line label styles if so you desire. Here if I go to new style, it brings me to the text style manager. This is also accessible right here. So let's adjust our text height. It's currently in sheet units, which it's still currently on the default TBC settings. I haven't played with that. Well, let's go with ground unit just for display purposes. Maybe something like 3 feet.
You probably also want to check auto flip and whiteout.
Yes. What auto flip does is it makes it so that the text is always horizontal left to right or vertical. I don't remember if it goes up the page or down the page, but it makes your text consistent. There's our text size. That looks better, but our gap is still quite large. So let's change that. That's here, just below text style. And let's set that to something like 300. See how that looks. It gives us a preview of what the text is going to look like down here. So that looks great. Yeah, there we go. This is what the whiteout does. It blocks out any color so the text is easy to read. And it sets it so your text is always left to right or up the page. Consistency is good. So also in the label style manager, we'll come back to this. Currently we have.
You still haven't showed us how big was the misclosure.
Yeah, we'll go back to that and then I'll come back to labeling. So our parcel is labeled, including the curve, and, when we're labeling the parcel, in order for there's two different misclosures I'll show you. The first is the geometric misclosure, and a second is a misclosure due to how your labels are rounded. In order for that to calculate, we have to have the arc chord bearing displayed, which we do currently. Just something to note that's important. So now we'll generate a map check report.
The radius, it won't be able to calculate it because there's no radius on the arc label.
Good point. You're correct. Remember, for an arc radius on here as well. Oh, I want it to be 2 below. The preview pane is quite handy. So here's our first map report. This is the one without a radius. This will be the one with the radius. So we have our project information. We have our latitude, longitude, project height. And then we have the traverse length, the total misclosure, 14 thousandths, and our precision ratio.
1400, 14,000.
31,000, that's pretty good.
So 1 to 31,000. This meets, in the United States, surveys are regulated by the precision ratio that they must meet. It's calculated by dividing your total misclosure over your traverse length, or the linear error misclosure, I believe. Sorry. The United States survey system's somewhat new to me. And then so for the misclosure, we have a northing, easting. I believe this is the coordinate of the start point of the misclosure line. And we have the bearing of that line. So it's 30 degrees southeast, or south 30 degrees east. And then we have the latitude and departure of that misclosure. And we also have, this is our labeling precision misclosure. So if you have your bearings and you have them rounded to the nearest minute, as I did on the example slide in the presentation, you can be confident in the map that you're producing that your labeling is not going to be detrimental to the misclosure of your parcels. So TBC will go and it'll calculate that for you and tell you what it is. It's 14 thousandths, so our labeling is accurate enough that it does not affect the misclosure at all.
So it seems your labeling, your misclosure from labeling matches your misclosure from geometry?
Yes, that's correct.
What you're saying is that if we choose a different rounding factor, we would typically see a difference there in the geometry versus...
Yeah. So that's something that we can dive into a little bit here. There's another page on here. We've got a nice drawing of our parcel with all of our labeling and our point numbers in place. This can be good for a variety of purposes, and it's nice to have that shown.
So in that other map check report, the middle tab there, there's no misclosure from labeling because you didn't have that arc defined. Is that correct?
That's correct.
So we would just have the misclosure from geometry in that report.
Yes. Okay. Because there are 3 variables or 3 numbers needed to calculate an arc, and it's unable to do that without having the 3 variables included in rounding. So here in the label style manager, let's take a look at some other additions. I'm going to go ahead and remove the background map to make it a little bit easier to watch and easier to see. So now here in the drafting tab, we'll go to the label style manager. And so I've just got the standard label style. Under lines here we have line length. I would like to also display my ground length. So here we have the ground length. I want it to be, let's do, not 3, let's do 2 above. We'll add that. Oh, there's a question mark right now. It's because the label style manager doesn't know what our scale factor is. So let's calculate that from our selection. Alternatively, we can use geodetics. This will have a live scale factor that updates depending on where in the project you are.
Which is probably not recommended in this situation.
This situation being 100 feet by 100 feet, there would be no point to do it. If you're working on a multiple township level size of project, then this would be something that you might be required to use because your labeling could potentially change from one side of the project to the other, or your ground distance rather, on your scale factor. So we'll use a fixed scale factor, we'll apply that, and now we'll go back here into the label style manager, and we now have a ground distance labeled. It's a little bit different than our grid distance, which is a good sign, but how do you tell the difference? So here I'm doing the line length again. You can tell because my grid length is highlighted. I can add a prefix here. We can do grid, and for the ground, we can add ground. Typically plans use one or the other. I'm just throwing this on for demonstration purpose, but this is something you can do. Also for your precision, you can opt to use your project settings for rounding or choose something different. This is where the labeling would come in. You can choose between your labels by clicking on them in the preview as well. So for our angle display, it's currently to the nearest second. So in order to adjust the precision, you need to opt to not use your project settings. This gives you the confidence that changing something in your project settings will change your labeling, unless you're using a label style which specifically does not use the project settings. Let's round to the nearest minute. But our other options here are 5 seconds, 10 seconds, 20, 30, minute, and then you can go all the way up to the nearest degree, if so you desire. Excellent. Over in arcs, it's a similar story. We can do our grid arc length, and we can do our ground arc length. Arc. There we go, arc ground length. Couldn't see it there for a second, sorry. And then arc radius, chord length, bearing, chord length, all sorts of things that you can have labeled here. I'm going to stick with, let's throw in our ground length as well. We'll call it ground. And let's also, that should be okay. We'll add that, but we'll put it 2 above. Excellent.
If you want to misclosure calculated from your labels, you'll also have to have a ground radius.
Let's do that. So the label misclosure, it'll calculate a different misclosure based off your grid and your ground. So if we have our grid and our ground distances, if we have a ground radius as well, call it ground rad, put it 3 below. So now we've got our grid and our ground distances and our radiuses. So let's create another map report for that, so we can see how the labeling updates accordingly. If you want to change your parcel name, say this parcel on the plan was 9,076. So if you type in the parcel name and you click, that'll update the parcel name. This cycles up to the next number as well. So if you're doing a row of parcels, you can go along and click, exactly. Excellent. So this is the same report, except this time we have a grid and a ground labeling disclosure. They are the same to the thousandth of a foot, but our precision due to labeling is slightly lower on the grid, and that has to do with how the numbers are rounded, but also that the grid numbers, it has to do with how the numbers are rounded. Excellent. So there's the workflow for one parcel. Would you believe me if I told you it was identical for multiple parcels? Let's go ahead and bring a few of them up here, shall we? So here in the Create Kogo, I have a Kogo collection already in place, and this is for this entire subdivision, the whole plan copied in. And this is all the text that was involved.
You can really kind of copy this to Notepad and send or email somebody the entire string.
Absolutely. I've got it copied here already. Okay. So if you type it in once, you can save it and you never have to type it in again. And depending on how fast you type, the bearings are automatically updated. So this was entered in by clicking. You can type it in, and your speed is only limited by how fast you can work the number pad. I'll close these other reports, remove some clutter. All right, so here we have our map check pane. Let's put this in, let's create a new layer. Something I learned the other day. If you click on any layer window in TBC and you hit the spacebar, opens up the layer manager. So if you regularly create new layers for things, we'll call this the Walden parcels. Excellent. And then we have create our parcels. Oh. There we go.
Once again, you didn't have to select all of the line work.
I've gotten in the habit. So some areas require you to have a parcel for the roadway. I've seen plans that do it. I've seen plans that don't do it. So if you don't need it, you can click on the roadway parcel and remove it. It'll take the roadway parcel out. If you want to rename them and match the plan, this starts at 9066, 9067. So let's here in 9066, and then we'll click on. You can go through and number the parcels accordingly.
Notice there's two flags there, Matt. Can you pop up the flags pane and tell us what those are?
Those two flags there. For 9087, this parcel here, it has a precision of 1 to 12,995. So here up in the project settings, under computations Kogo, we have our minimum precision established. In the United States in particularly, other countries perhaps as well, you'll have a minimum precision that's required that your survey meet. You can enter that value here, and then you can be confident that your parcels will meet that minimum disclosure as well. That way, if there's a lonely surveyor out in the field and he's making sure that your parcel closes and he finds that, that way he will never be able to find out that it doesn't, because it always will.
Good. I think we need to start wrapping up. We have quite a few questions, Matt. Is there another thing you wanted to show?
I was just going to then label these parcels.
Sure.
All right. So we've created the parcels. Let's now label the parcels. Each of the parcels is selected, and this is pretty. Oh, go down to the right layer. Excellent. I'm not clicking on the arrow over there because I have a webinar toolbar that's right there in the way. That's why I've been double clicking on it. In case anybody watching thinks I'm incompetent, I have an excuse. Excellent. So here we all of our curves have been labeled. We can adjust that in the label manager, and then we can use in the drafting tab, we can put those curves in a table if so we desired. I believe we have a tutorial on how to do that. And everything. So once our parcels are all labeled, it labels, so this parcel has a boundary around it. This parcel has a boundary around it. Each of the boundaries is labeled for the map check report workflow. This is so that each of them display properly on the drawing and the map check. This can be avoided by not using the labeling in the create Kogo command, but doing it in the drafting ribbon.
Sounds good. With that, we'll have to there's a few more things we wanted to show, like the legal description report where it was, also how to put things in a curve table, but in the extent of time, we may need to do some other time. But we did get quite a few questions that we want to at least take a minute to answer a few of the questions that we can. Brandon was asking about training opportunities with TBC. Definitely email us. We actually got some additional bandwidth to provide training on the individual basis, or in the areas where we have Trimble distributors that can provide those trainings. We can definitely connect you with a Trimble distributor, so you can kind of get more detailed insight and kind of get a proper training on how all of this works. Um, So we do. Neil was asking, do we have the auto flip is like right readable? That's correct. So in addition to that, you have the ability to right click on a label and do flip aside if you want to flip the sides on which the label is on, or you can also flip the bearing and azimuth. Mike was saying he noticed that the parcel distance has changed when you created a parcel. That is not desirable. You should not change the record plat distances. Not sure that. So, Mike, you're referring that you want to keep the parcel distances same as on the original PDF, and I think that is fine. So we were just demonstrating how you can do both workflows.
Yeah.
So. Yeah, the distances were, he's probably referring to the fact that you changed the labeling precisions, and that would change the values.
Or using the...
Or do you think that's what he's talking about?
Yeah, if you're referring to label, we just changed it for the demonstration purpose. We changed the label rounding, but you're right. You probably want to keep the consistency with the original plot. Adam was asking, can you change the bearing of the last line you drew before the curve so that it reads down the page but leave all other labels alone? You can certainly label lines individually, so we were just kind of showing a mass label. You can remove a label from this line, for example, and you can apply different label styles to one particular line.
Yeah.
I hope that answers the question. Mauro is asking, I see you have a ground scale factor, however you have a scale factor. What is the difference between the two? Troy may want to address that.
So the scale factor for labeling, it can be a different value than that for your entire project. Usually the local site settings establishes a project-wide scale factor, but in the vicinity of your COGO work there, you can choose a different scale factor so that the labeling is local to that part of it. So it's just like having two different scale factors allows more flexibility.
Good. Martin was asking if we have any templates for plot creation. If so, where can I find them? So in the legal description writer, we have some templates we provide. We also have some drafting templates that you can use to put this on a topo map. So on the drafting tab.
So the legal description writer. We select a starting point. Path. Preview. Here's the edit window, and then on the preview window.
So Matt is showing here how the legal description, one of the templates work, but you can certainly have your own template.
You didn't.
I don't have the parcel selected. That's it. There we go.
Try again.
So then, writes up the legal description for you. Starting point, commencing at the point of beginning, runs through all the lines. If there's one thing that you want to change, you don't like how it is, you can enter the debugger mode and change the text that is related to that.
You can save this as a different template, so you can kind of take our existing starting template and fully customize it to match your local needs. For the drafting, in the drafting tab, if you click on the drafting tab, on the left of the drafting tab, there's a command called drafting templates, and this kind of takes you to a folder with the various drafting templates. If you want to put this on a piece of paper, so
drag it in, it creates it for you. For the labeling, the direction of the label follows the direction of the line. So if the line direction is reversed, then the labeling will flip.
But if you can select that label there, Matt, and right-click and say flip azimuth bearing label, so that will change the direction of the label. Yeah.
I was thinking of rotating the text 180.
That's fine. So that just kind of want to close out with a few of the kind of closing remarks. So on our TBC website, you can find a variety of useful information, link to our YouTube channel, link to our TBC videos. There is also a link to a field to finish competition. So we are rewarding the best TBC project with a full paid trip to Trimble Dimensions. So if you submit a fully drafted and completed project in TBC, you kind of enter a pool and you get voted on users get to vote as well, and we reward the best project with a flight, accommodation, and registration for Trimble Dimensions. So if you have some awesome projects you've been working on recently, it's a great opportunity to get to Trimble Dimensions. So take advantage of that. Our YouTube channel contains a lot of stuff that we've discussed today. So there is a video on Legal Description Writer. There's a video on Create Kogo. I believe we have videos on proportioning there as well, or maybe not yet.
We will.
Yeah. So definitely use our YouTube channel as a source of information. And then if you missed any of the Power Hours, so we've done an in-depth legal description and Kogo in the past as well. So you can find those in our archive, and you can always go back and watch Power Hours, including this one here, is going to be available on this website. We have a TBC community page, so if you want to interact with us, so if you want to interact with other users, we encourage you to post comments, ask questions, and kind of leverage that TBC community out there. If you want to try any of this stuff, you don't have TBC Advanced today, please reach out to our distribution partners. So we have distribution partners all over the world. Each one of those can supply you with a 30-day code, so you can start playing with TBC if you don't have a license today. Our next TBC Power Hour is going to be August 29th, and we have some guest speakers from Delaire. We will be talking about processing Delaire data using TBC aerial photogrammetry module. So I hope you enjoyed our webinar today. Want to thank you for your time, for your attention. Apologies for going 10 minutes over time. Thanks to Matt and Troy for supporting this webinar. Appreciate it, guys.
No, this was fun.
Yeah. And happy surveying.